everyone, I'm Laura Caron, and I will be doing the third and final portion of the Coral Reef Group's presentation. This section is entitled Storms, Earthquakes, and Coral Reef Communities. Much of modern media's focus looks at bleaching, acidification, or pollution when addressing the future of our coral reefs. What needs to be understood is there are numerous sources, aside from those caused by anthropogenic influence, capable of widespread devastation within reef ecosystems. Coral reef communities around the world are facing imminent threat of destruction by the violent forces of natural disturbances such as hurricanes, cyclones, typhoons, tsunamis, and earthquakes. Extensive deformation caused by uplift or subsidence from tectonic activity is often overlooked when thinking about impending hazards to coral reefs. Likewise, storm systems impact more than just the terrestrial and aquatic horizons on Earth. Far-reaching effects can be seen below the surface of the oceans. Species loss or death, successional changes, destabilization, population shifts, and changes in dynamics of coral reef communities have dramatic and pervasive cascading impacts on oceanic biota. Prevailing opinions within the scientific community also predict that these natural disturbances will be compounded and intensified in the future as the effects of climate change are felt. Disturbance regimes and perturbations affect all ecosystems. Although many anthropogenic influences cause our ocean biomes to depart from their normal state, there are also numerous natural disturbances which can wreak havoc on coral reef communities. As in Sousa's definition of a disturbance, examples in this environment of discrete natural disturbances include earthquakes, lava flows, plate convergence and divergence, storms, cyclones, typhoons, hurricanes, and tsunamis. According to the National Oceanic Service and the National Oceanic and Atmospheric Administration, the Pacific Ocean Basin is home to the most species of corals, spanning much of the tropical and subtropical oceanic regions on Earth. It is here that there is also the highest frequency of tectonic activity in the Ring of Fire, or the Pacific Rim, along the subduction and collision zones of the Pacific Plate. Earthquakes in the Pacific have potential to cause devastating damage to coral reef communities. Along the tectonic boundaries of the Ring of Fire, there are predominantly active boundaries with a wide range in classifications of movement. Some are divergent, some are transform, and some are convergent boundaries. At many of these divergent locations, such as the East Pacific Rise or the Mariana Trench, there is significant seafloor spreading occurring. These images are just a few examples of the devastation of coral reef communities worldwide where tsunamis or tectonic uplift have caused widespread reef exposure, resulting in death of the community as a whole. Reef systems can be classified into four main types: atolls, fringing reefs, barrier reefs, and patch reefs. In any of these reefs, you can find reef builders who are responsible for providing essential structure to the ecosystem. The Coral Reef Alliance, an NGO working to educate and restore coastal reef communities, discusses coral reef ecology at length, highlighting the unique roles each individual species within a coral reef play. Despite the strength provided by hard coral reef builders through their calcium carbonate skeleton, reefs are delicate systems. These delicate systems are not only extremely sensitive to minor changes in their aquatic environment, but are also highly susceptible to destruction from excessive wave turbulence caused by large storms, cyclones, or tsunamis. In many key studies on natural disturbances to reef communities, only a few were able to propose very basic concepts for future management use. Much of the work was focused on monitoring, identifying, and mapping the effects of discrete events, rather than developing methods to expand the application of their conclusions on a broader scale. Due to the unpredictable nature of storms and earthquakes, there is not enough existing research to establish necessary baselines for future mitigation and restoration efforts. The complexity of each reef system also contains too many variables, which are often not repeated naturally in other locations, whether it be specific salinity, topography, solar exposure, species communities, successional pathways, underlying tectonics, ocean currents, superficial air currents, reef type classification, depth, water clarity, existing pollutants, or sediment load balance. Consensus surrounding the episodic cycles of destruction and renewal in the face of disturbance accounts for much of the variance in reef biomass of adjacent reef communities or reef zones. Destruction of vital hard corals or loss of essential algae species like zooxanthella occurred regularly. Many species and coral communities share mutualistic symbiotic relationships that, if disturbed or damaged, can destroy the habitat quickly. Minor trophic cascades were observed based on loss of species at various sites. Substantial efforts are being made to track recovery trajectories, stochasticity of communities, intensity of damage based on reef type, and species-specific damage, as well as total loss from backwash and erosion. The majority of conclusions were not only justified, but also logically supported with intensive field study data. Many of the key studies in this field articulated an understanding that further research in each of their site locations, like the reef terraces of New Zealand, Japan, Australia, archipelagic island chains off the Indian coast, the Gulf of Aqaba, and the Philippines, are needed, as well as in each of their respective sub-focuses. Future research priorities need to concentrate on a few main criteria: interacting disturbance regimes, increased frequency of storms due to climate change, increased intensity of storms due to climate change, recovery trajectories based on reef type, and monitoring with a goal of adaptive management and mitigation strategies. On behalf of Nathaniel, Marissa, and myself, we'd like to thank you for watching our videos as part of the Coral Reef Communities Group Talk. We look forward to any feedback and watching your videos as well.